So in this lesson, we're talking all about forces. And one of the really big forces that we have to take into account nearly every time that we do a problem is going to be gravity. So we're going to look at how to calculate that gravity force. And to do that, we're going to do the gravity force lab. So the purpose of this lab is to figure out how much gravity is acting on different masses. So we're looking at that relationship between the mass and the gravitational force acting on that mass due to the Earth's pull. So what you're going to need is a spring scale. Depending on your kit, they're going to look differently. There's lots of different types of spring scales. This is one that I have in my classroom. Very simple. It looks like a fish scale, I guess that's what it's called. So you just hang something on it and it pulls that down and you read the thing. Some of them look like this. So you can have this little square one. You have two measurements on each side. Some of them are round. So depending on your kit, you're going to have a different type of spring scale. I'll use this one because I think it might actually be easier to see a little bit. Most spring scales have at least two different scales on them. If you can see this very well, I don't know if you can see that very well with the camera. This is the mass side. So there should be one that is labeled in grams or kilograms. That's going to measure the mass. Now that is your first variable that you're going to measure. So if you don't have anything that says what mass is, if you don't have like the little, don't have the hanging masses like this, you're going to have to measure the mass of whatever object that you're measuring. So you're going to hang it on your spring scale. It might be easier. A lot of them have hooks up here. If you hang this, life gets a little bit easier. So you can hang this up and keep it steady. You do want to make sure that it is zeroed. So if you look right here, this little flat part right here is what's going to be the measuring part of it. You want to make sure that starts on 0 when it's just hanging there. There's different ways to adjust that. This one, for instance, you move this back and forth. You can kind of see that going up and down as I do that. Now I need to get it back. There we go. Okay, so our scale is zeroed. You're going to take the mass, or whatever you're measuring, it does not matter, and put it onto your spring scale, okay, like so. Now again, you can kind of see if you're not holding still, if you're jiggly, it bounces up and down. So you do want it steady. So again, hanging it on something can be handy. So you're going to measure the mass. Precision is really, really important in this particular lab. So make sure that you're holding steady and you're estimating in between the lines. All right, so you want it as the most precise measurement that you can get. So this is your mass. And then flip it over, and there should be a Newton's scale. So this is going to measure the force. Now, as you start taking this data, you're probably going to notice a pattern. You don't even have to graph it. You're going to notice that pattern. So you have your mass, you have your force. Then you're going to change the mass. So you're going to take this off, put something new on. I think this is probably going to be too heavy for this scale. Not quite. Okay, you're going to put something new on. Do the same thing. Measure the mass, measure the force. Okay, that's the data that you're taking. Now, when we go to graph this, I'm changing the mass, right? So that's your independent variable. So I am changing the mass. I'm looking to see how the mass affects the force of gravity. So your independent variable is going to be your mass. That's going to go on the x-axis of your graph. And we're looking at how the force of gravity changes as we change that mass. So that's your dependent variable. That's going to go on the y-axis.